Okay, so for this one, we have to find VO and the complex power supplied by the source. So first thing we're going to do is detach this portion of the circuit, and we're going to rewrite the circuit like the following. Okay, so first we're going to find V Thevenin, and since we know I1 is 0, V Thevenin should pretty much be V1. And since I1 is 0, there's no mutual inductance between these two. So that means I2 is also 0. And this resistor is useless, so V2 is equal to VO here. Okay, so now let's find that Thevenin, and it's pretty much supposed to be V1 over I1, and we know V2 over V1 is equal to the turning ratio, and I1 over I2 is also equal to the turning ratio. So V1 should be V2 over N, and I1 is I2 times N. So this is pretty much equal to V2 over V1 times 1 over N squared. And V2 will be pretty much the impedance value of these two times the current I2. Okay? So this will write as 16 minus 24J. Oh, and the reason it's not minus 24 is because I forgot to add, we usually add like a test charge here. So there would be like current passing through here, and that pretty much generates a mutual inductance. Okay, so this is pretty much just I2 all over. Oh, sorry, this is not V2 over V1. Sorry, V2 over I2. My apologies. And these two just cancel out. So you can quickly find VTH. It's 16 minus 24J all over N squared, all over N squared. And we know the turning ratio is pretty much N2 all over N1. So 4 over 1, which is 4. So it's just 4 here. And that's just 16. So it's just 1 minus 1.5 J, and that's your Z Thevenin. Now we're going to draw this circuit, the Thevenin circuit. So we include the load we omitted, so the red part. So this is 2 ohms here, 120 phasor 0. Then we add the Z Thevenin load. And then we add the VTH load, V Thevenin load. And V1 is equal to V2 over N. Okay. Now to find VO, we need to find I1. So to find I1, we pretty much first have to just ignore this voltage source and do a mesh. So it's minus 120 phasor 0 plus 2 plus 1 minus 1.5 J. I1 is equal to 0. So it's 120 phasor 0 is equal to 2. So it's 3 minus 1.5 J. And I1 will be equal to 120 phasor 0. Let me find the phasor of this. So it's 11.25 phasor minus 26.56, and that's 35.78, phasor 26.56. Okay, and now we have I1. We can use that to find I2 because we know I1 over I2 is equal to N. But before we use that formula, we have to check this list. So so pretty much this portion, hold on. Which part on this list matches this portion of the circuit. So we see I1 and I2 are both leaving. Sorry, I1 is moving into here and I2 is leaving. And we see the dots are on opposite side of each other. And we see this one as a match. And we see V2 over V1 is equal to minus N. So that means, and we see I2 over I1 is equal to minus 1 over N. So that means I1 over I2 is equal to minus N. So I2 is equal to I1 all over minus N. So minus 4. So that's minus 8.945 phasor 26.56. Distribute the negative into the phasor, so we can add 180. So that's 206.56 degrees, and that's your I2. Okay, now we can find VO. VO is pretty much just the current passing through the capacitor, which has an impedance of minus 24J. So it's 8.945 phasor, 206.56 degrees. And before we solve this, we will have to turn this into phasor format. Sorry, in polar format I meant. So 8.945 cos of 206.56, that's minus 8. And then same value, but sine 206.56, and that's minus 4J. Okay, so now distribute this into all of here, and that's 192J minus 96. Now put this in phasor format to have your VO. So that's 214.66 phasor. So pretty much to get the phasor, tan inverse 192 all over minus 96. And that's minus 63.43. I double check this on the Cartesian plane. That lies down here, but this value, so 192J, that's up here, then minus 96, that's over here, so it's going to be somewhere in this direction. That means we have to add or subtract by 180. So let's add by 180. And we get 116.57 degrees. So that's the value we're using. That's your VO. Now, your complex power is pretty much going to be S equals VRMS times IRMS of the conjugate of the current. So VRMS is, so we want the complex power supplied by the source. So VRMS is 120 phasor 0 degrees, and IRMS is this value, but we take the conjugate of it. So it's going to be 35.78 phasor 26.56, and the conjugate is, we just put the negative in the phasor area, and that's 44,000 293.6. Phasor minus 26.56 watts.